Hey guys, uh, this is going to be part 2 of that same problem I was just doing in the previous video. And this time it says, find a particular solution, y equals f of x differential equation. This is, again, it's the same problem, so we're talking about the same differential equation from the previous problem. But they tell me that f of 2 is equal to 0. So remember that when they say particular, that's not at all how that should be written. When they say the particular solution, it means like actually find the differential equation. So they say f of 2 is equal to 0. So because we only know one way to solve differential equations, that's what we're going to have to do here. And I would think of this, the first thing to do is to separate variables, because that's our method for solving this thing. So basically, I'd multiply both sides by dx, which puts the dx on top over here. Then I divide both sides by y minus 1, which puts the y minus 1 down here. And I end up with dy over y minus 1 equals dx over x squared. That's not a negative, that's just me not being good at using this thing. So there we go. This is step 1, you got to separate variables. Now I'm going to maybe rewrite this a little bit so I can see a little better what's happening here. Dy over y minus 1 is okay the way it is. This is like 1 over y minus, oh, let me rewrite it as 1 over y minus 1. I want to write it like this. And this one is for sure going to be easier for you guys to do if you think of it like x to the negative 2 dx. This is just a rewriting of this thing. And now I'm going to do integrals because I've separated the variables. I got all the y's and dy's on one side, the x's and dx's on the other side. Now, the antiderivative of 1 over y minus 1 is a natural log of y minus 1. And this equals the integral of x to the negative 1 is x to the negative 2 is negative x to the negative 2 plus c. And I would like to plug in my initial condition here right off the bat, but I can't. Because if I plug a 0 into here, I'm going to get the, well, not the way I wrote this, and this was kind of my mistake, which is, this is the natural log of, let me write this a little better. You all may remember this is a natural log of the absolute value of y minus 1. Because if I plug a 0 in and I get negative 1, I can't do the natural log of negative 1, but I can do it if it's absolute value. So next step is to plug in my 0.02. So I'll indicate that by doing, this just kind of tells you what I'm doing. Natural log of absolute value of 0 minus 1 equals, oop, I wrote this wrong over here. I did that wrong twice. I said it twice wrong, so. All right. Negative 1 plus c. So that's negative, x is 2. So that's 1/2 plus c. So natural log of, this is the natural log of 1. Is negative 1/2 plus c. The natural log of 1 is 0. So 0 is negative 1/2 plus c, which means that c is 1/2. So now I'm going to go ahead and plug that back in, where I have natural log of y minus 1 is equal to negative 1 over x plus 1/2. Now I can just exponentiate, which is a very common thing in these problems. I get y minus 1 equals, well, let me go back and just write out the step in between there, because this is really from a previous lesson, but just so that we're all on the same page. What I did there was I did e the ln of y minus 1 equals e to the negative 1 over x plus 1/2. And this side, e to the ln of y minus 1 just becomes y minus 1. And this side just stays e to the negative 1 over x plus 1/2. And the last step is to add 1 to both sides. So we get this thing solved for y. Exactly. So this here is the answer to the question, find a particular solution y equals f of x. Let's just really quick, I'm going to review the steps. I separated variables here. Then I rewrote these two terms so that I could take the integral more easily. Then I took the antiderivative integral of both sides, making sure to include that plus c. Then I used my given point, my initial condition, which was f of 2 equals 0. I used that to find c. I ended up with c as 1/2. I went back to my original integrated expression here. I plugged that 1/2 back in for c, and then I solved for y. In this case, you had to exponentiate and then add 1 to both sides, and then this is the answer. So this is just like the slope fields, the differential equations and slope fields questions usually have something like this, where there's the first part is to do something with the slope field, and the second part is to solve a differential equation. So that's why I did that second part. That's really from the previous lesson, but they will be included in the same problem. So I'll do the second kind of problem in video number 3.